Most everything in this image you guys should already be familiar with, nothing new. Picking up, dropping off, nutrient-rich. Here's a big one, nutrient-rich blood, straight to the liver. Straight to the liver. We're going to pick up all our nutrients, we're going to take it straight to the liver. Nutrient-rich blood, straight to the liver. Okay, so intestinal glands. Now this is kind of important because, again, we're right back to where we were with what does what. So intestinal glands, brush border enzymes on the surface of intestinal microvilli, break down materials in contact with them. Okay, so think about this. If you take a broom and you sweep it across the floor, does it move the material that's on the floor? It does. Think about these brush border and the enzymes there. As they brush against the food that's moving past them, they break it down. Okay? So enteropeptidase, a brush border enzyme, activates the pancreatic proenzyme trypsinogen. Well, if it's trypsinogen, what's it gonna become? Trypsin. Generating pepsinogen, pepsin. Okay, I know. Okay, enteroendocrine cells produce intestinal hormones such as gastrin, CCK, and secretin. All needed to activate the digestive process. Let me say that one more time. All of those are needed to activate the digestive process. Duodenal glands, okay, submucosal glands, copious quantities, that's a great way to say it, okay, of mucus. When chyme arrives from the stomach, we've got to protect the small intestine from the acid, so copious amounts of mucus. Yay. Okay. Intestinal secretions, watery intestinal juices, about 1.8 liters per day, enter the intestinal lumen, moisten chyme, assist in buffering acid, keeps digestive enzymes and products of digestion in solution. Okay, it's got to be wet. Not going to work if it's not. Okay? Intestinal movement. Well, this is all about peristalsis. So nothing new going on here. Okay? Parasympathetic stimulation accelerates local peristalsis, and there's our pal segmentation. Okay? Segmentation is going to break it into smaller pieces. Peristalsis is going to move it on its way. Gastroenteric, we're talking about stomach, small intestine reflex, stimulates motility and secretions along the entire small intestines. It says gastroileal reflex triggers relaxation of the ileocecal valve, allows material to pass from the small intestine into the large intestine, and at that point it becomes what? Roberta. Because you're sleepy Smurf, I'm going to try to wake you up with all these great questions. When we go from the small intestine to the large intestine, what does the name become? It goes from a bolus of food to feces, yeah. Nothing crazy going on there, feces. So there you go, central gastric reflex. This is going to stimulate motility. We've got to get that stuff moving because here we go. We're dumping 3 milliliters at a time. The stomach's going to say neutralize, emulsify, segmentation, and move along. 3 more. Neutralize, emulsify, segmentation, and move along. So literally the gastric enteroreflex is basically circular. All right? So break it down, emulsify it, segmentation, move along. And it just keeps going until the food's gone. Now the numbers, depending on what you ate and how much you ate. Okay? 2 to 4 hours, about normal, depending on how fatty the food is. Okay, pancreas, well, this is interesting because we already know that the pancreas is also an endocrine exocrine gland. Okay, in this case, we're going to be mainly talking about its exocrine functions. All right. Head, body, tail, not too worried about this. You should know where it is located, bless you. Okay. It does have specialized cells, and these specialized cells secrete certain things such as glucagon and insulin. Okay, let's just keep popping through this histological. There's the position of it. There's the position of it. Now let's think about this. The tail all the way down at the end, and we saw this in the pigs. You guys remember the pigs? We saw the little flappy part, the little tail. Most of you found it. For those of you who didn't find it, that's okay. Okay, poor pig, you killed a pig. Okay, but notice we come all the way through pancreatic duct. The pancreatic duct actually leads to the common bile duct. Okay, and then the duodenal papillae. Okay, the sphincter of Oddi. Well, I'm not kidding. That's what it's called. That's where everything's going to be secreted into the duodenum. Okay, they join together right at that point, and they come out at the same spot. And what's really crazy is when you're actually in there with a scope looking at it, you can actually watch it open up, and bile will come out, and then it'll close. It'll open up, and a little bit of bile will come out, and it'll close. It's crazy to see that. Okay, this is just talking about the different types of cells. Pancreatic juice, exocrine cells. Now, we already know the endocrine cells. We already know those. So there's nothing new going on there. But the exocrine, okay? These are epithelial cells of the duct system. They secrete pancreatic juices. Now, if these pancreatic juices are coming in right at the duodenum, what do you think the majority of the juices are going to help us do? Okay, what is the bolus of food coming from the stomach into the duodenum? What's it like? Yeah, it's very acidic. So the majority of these juices are going to be what? Basic. Yeah, basic. Okay. Secretes about 1,000 milliliters of pancreatic juice per day, controlled by hormones of the duodenum. The duodenum is going to dictate this. Okay, contains pancreatic enzymes. So, pancreatic alpha amylase, pancreatic lipase, nuclease, all enzymes to do what? Break down the foods that have already started to be broken down. Amylase, carbohydrates, lipase, lipids. Okay, nuclease, well, nucleic acids. Okay? And we're going to break down a whole mess load. 70% of all pancreatic enzyme production secreted as inactive proenzymes, activated after it reaches the small intestine. So let me elaborate on this. So 70% of all pancreatic enzyme production secreted as inactive proenzyme, activated after reaching the small intestine. Well, what is found in the small intestine before we neutralize it? Acid. In the presence of acid, we're going to go ahead and start secreting all of these pancreatic juices. Okay? In the presence of acid and lipids, which we know some of these break down lipids, we're also going to secrete bile. And bile neutralizes acid and emulsifies fat. Let me say that one more time. Bile neutralizes acid and emulsifies fat. So it's no surprise that when that bolus of food, that 3 milliliter spurt of food comes from the stomach to the duodenum, the acid is a key ingredient for activation of all this stuff. Acid. HCl. And what cell produces HCl? Parietal. Okay. The liver itself, okay? All you really need to know about this is that our nutrient-rich blood goes to the liver for processing, and here's the big one, the liver produces bile. The liver produces bile, not the gallbladder. The gallbladder is just a storage area for bile. The liver produces bile. Anatomy of the liver, well, again, found in the visceral peritoneum. Okay? Anatomy, left and right lobe. The liver is pretty interesting considering it can regenerate itself. Notice the gallbladder is tucked up underneath the liver, and that's because that's where we're going to store bile. Okay, hepatic portal vein, hepatic artery proper. We're talking about the input and output of blood so that it can be cleansed and nutrients can be taken care of. Nutrients. Okay, hepatic blood supply, about 1/3 of the blood supply. Arterial blood from hepatic artery proper, 2/3 venous blood from hepatic portal vein, originating at the esophagus, the stomach, the small intestine, and most large intestines. Kerpow. Okay, this is just general histological organization of the liver, so we're going to skip this. Skip. Hepatocytes, those are liver cells. Okay? Adjust circulating levels of nutrients through selective absorption and secretion. In a liver lobe, form a series of irregular plates arranged like a wheel spoke. Kupffer cells, what are these? They are liver cells. What do they do? Kupffer cells. Where did we hear that before? Immune system, maybe? I think so. Okay. Bile duct system. Liver secretes bile fluid. Okay, you do a network, narrow channels, the bile canaliculi. That's your guys' favorite word right there. Okay, start laughing. Bring it on. Kids nowadays.
Oh, yeah.
Okay? So, right and left hepatic ducts collect bile from all bile ducts, unite to the common hepatic duct. Bile flow from the common hepatic duct to either the common bile duct or the cystic duct. The cystic duct, we're referring to the gallbladder. So we're going to go straight through to the duodenum, where we're going to store in the gallbladder. Okay, passes through the omentum, just generalized information. Okay, there's the gallbladder. Notice that we can actually go into the gallbladder itself. The cystic duct, bladder, okay, gallbladder. Okay, and this is a close-up shot of the common bile duct, the pancreatic duct, okay, the hepatopancreatic sphincter, okay, and then boom, here's the intestinal lumen in the duodenum. So it's where it's going to empty. This is actually a radiograph, okay, and we call this fluoro in the hospital, and basically what we do is when we're looking at it like this is because we're actually removing gallstones. Biggest majority of the time when we do an x-ray like this is to see if there are any gallstones in there. They're not using that for this, they're just showing you a picture of it, but yeah, we would be looking for gallstones. Okay, and we can actually, this is the biliary tree, okay, we can come up here, and stones usually get lodged right in this area. We can come in, inflate a balloon right here, and then pull the balloon down and pull the stone out. Okay, people don't even feel it. They can feel the stone because it's a backup of bile and it hurts. Go ahead.
Is it just made up of like a more compressed?
It's the crystals from bile. So bile has to be in water, and if there's not enough water, it crystallizes and becomes a stone. So it's crystallized bile. There's not enough fluid. Yep. Could be a number of things that cause it. In fact, we were doing a study in Colorado because for a period of time, over about a year, the average age was between 21 and 26 female after one child. We had probably, 14 or 15 ERCPs, the removal of stones. Yeah. So we had to, we logged those numbers down because we were like, hello, that's, red flag. That's a very precise age. And every single one of them had at least one child. So, well, I think they're still doing the research. I talked to one of the docs about 6 months ago, I think it was. They're still doing the research on it, trying to figure out why. It could be that people are inherently dehydrated in Colorado anyways. So everybody walks around slightly dehydrated there anyways. So, all right, so there you go. Oh, look at this. There's our friend CCK. CCK by the duodenum triggers the dilation of the hepatopancreatic sphincter and contraction of the gallbladder. This ejects bile into the duodenum. Oh my goodness gracious me. CCK actually has a function. Yeah. Okay. What does bile do? Well, in the lumen of the digestive tract, bile salts break lipid droplets apart by emulsification. Kerpow. Okay, physiology of the liver. Well, metabolic regulation, bile production. You guys need to know that. Okay, processing of nutrient-rich blood. Okay, so metabolic regulation, composition of circulating blood, nutrient metabolism, waste product removal, nutrient storage, drug inactivation. Okay, so in other words, cleansing. And when you drink alcohol, really, guess where it's going? To your liver. Okay? So, and think about it this way. Your liver actually treats alcohol as a toxin. So if you drink copious amounts of alcohol, I'm not talking about just one beverage, I'm talking about copious all the time, that means your liver's constantly trying to regulate that toxin. In that process, it gives up some of its other processes, such as nutrient storage. Well, it increases that process. Nutrient metabolism, it stops that process. So what happens to your liver? It becomes fatty. So if you look at the liver of someone who's a chronic alcoholic, guess what it is? Fatty. All right? So composition of circulating blood, what is it doing? Well, it's removing and stores excess nutrients. Removes and stores excess nutrients. And we know where it stores it. We don't even have to talk about them. That's right. Okay, metabolic activities, well, boom. It's about breaking down and processing everything. Vitamin storage, mineral storage, waste product removal, amino acid metabolism, lipid metabolism, carbohydrate metabolism. You stop that process, let's just pack it on somewhere. Okay, let's see. Hematological regulation, we're talking about the blood, receives 25% of cardiac output. Okay, removal of circulating hormones, synthesis of plasma, removal and storage of toxins, synthesis and secretion of bile. Liver. Okay, function of bile, emulsifies fat. Gallbladder stores bile. Region of the gallbladders, I'm not too concerned about this. Cystic duct is talking about the gallbladder proper. Okay, and CCK, hepatopancreatic sphincter, remains closed until CCK is there. CCK says open, release, let it go, flow. Okay, then we emulsify fat.